Doc,
Yeah.
before I give you the session, something I want to ask you.
Yes.
Your name is Michael.
Yes.
What is this, Doc?
So Doc is a very old nickname.
Yes.
It is from when I was in middle school.
Yeah.
And it is because I was a classic smartass. So I was given the name Doc Logic as an insult. And I owned it.
Yeah.
And it stuck. So, yes.
Okay. You're welcome.
Yeah, thank you. All right, so the technical debt trap. That's what we're here to talk about today. I'm assuming that most of you are familiar with the term technical debt. Is that a fair statement? Yeah? Okay. And raise your hand if you have some kind of technical debt on your current project. Yeah. All right. This is my usual, I am so-and-so. So the conference hashtag is the first one here. I believe I got that right. This talk is technical debt, and I'm Doc on Dev, and you can find me anywhere as Doc on Dev. I happen to be the co-founder and CEO of CTO2, and we do process and leadership coaching. But that's not what we're here to talk about today. So we already agree that we know what technical debt is, and that we all have some of it. And as we kind of go through this talk, I'm going to look for some participation from the audience, and now is one of those times. The first thing I want to ask is, what is technical debt? So anyone that's brave enough, if you think about this phrase, technical debt, what does it mean to you? When you say it, what do you mean? Not all at once. Bad decisions from the past coming back to haunt you. Okay, I think it's a fairly common definition of technical debt. Any others?
Code that has to be maintained.
Code that has to be maintained? All right. Yeah. So I think these are like some fairly reasonable definitions of technical debt, right? Stuff that we've heard. I want to talk a little bit about the history of the actual phrase, the actual term technical debt, where it came from, and kind of why, right? And then we'll talk a little bit about sort of what's happened to that over time. So can anybody tell me who this guy is? This is Ward Cunningham, correct. So what do we know Ward for? Anybody have any ideas? My opinion? Everything. Wiki, Ward. Software patterns, Ward. Fitness and fit testing, precursor to all of the basic automated testing we do today, Ward. Extreme programming, Ward. Pretty much what we do today originated in the mind of Ward Cunningham. Right now, in 1992, Ward published an OOPSLA paper in which he spoke for the first time publicly about technical debt. And what he told us was that shipping first-time code is just like going into debt. Little debt speeds up the development, right? And as long as it's paid back pretty quickly with a rewrite, everything's fine. And I think, kind of based on the definition that we've shouted out today, that's similar, right? But Ward goes on to say, look, the danger occurs when the debt isn't repaid, right? Every minute on not quite right code counts as interest on that debt. I had the good fortune of meeting Ward maybe 10 years ago, and have had the opportunity to pair with him and chat with him quite a bit. And one of the things I know about Ward is that he's actually kind of soft-spoken. He's very deliberate with his words, though. And so sometimes when Ward says something, we hear him, but we don't actually hear him. You know what I mean? So what I want to do is I want to hone in on this particular sentence. So the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. I'm going to pick this part apart a little bit. The first thing that I notice is that Ward uses the word danger. He doesn't say the challenge or the hurdle or the problem. He uses the word danger. And danger should invoke fight or flight kind of response. This is something that we should be very concerned about, right? It's not just kind of a thing. He then goes on to say, every minute spent on technical debt counts as interest, right? He doesn't say every year or every quarter, not every iteration or even every day. He says every single minute that we spend on technical debt is dangerous. And what, by his definition, is technical debt? It is code that's not quite right. He doesn't say messy or shoddy. He doesn't say slapped together, poorly tested, poorly written. He's talking about code that's just a little bit off what we actually need. And every minute we spend on that is dangerous. Now, I'm also here to tell you that technical debt is actually good. How is that? How is it good? Well, it's because technical debt, by Ward's definition, is actually a strategic design decision. Right? What we're doing is we're making a decision to move something into production a little bit faster than we normally would, to get quick feedback, and to adjust our design. So what Ward's actually talking about when he talks about technical debt is the difference between what we've built and what the market actually wants or needs, right? He's not actually talking about the internal quality of the code. He's talking about just the difference between our current implementation and what it is that the actual market needs. Now, it turns out that sometimes then technical debt is not necessarily a strategic decision. Sometimes we don't actually do it on purpose, and it becomes an indication of learning. So we moved something into production. We thought it was going to be the awesome. We thought everybody was going to like it. But the market responded in a way that let us know that blue buttons are ugly, please make them green, or whatever else it was, right? So in this case, we now know what we need, and we can make an adjustment. Right? The implementation doesn't match what the market actually wants. Technical debt is also a metaphor. Now, in Ward's case, it is a metaphor for here be danger. We have code that's not quite right. It doesn't match what it is that the market wants, and every minute that we allow that, our business is in danger. Right? And I love metaphors. They rock. We reason through metaphors. They are a great way for us to communicate. Right? We reason by analogy. These allow us to establish some kind of a simple understanding of a complex problem. Right? Especially if, like, I know about a particular domain, I know about a particular topic, but you don't. Right? And I want to explain that topic to you. There's something else that both of us know about. I can help you understand by telling you how the things I need to do in code are similar to debt as a metaphor, right? I can use this thing that we both understand. And it turns out that this is why Ward actually chose debt as a metaphor. What he was doing was he was explaining to his business customer refactoring and why they were going in and making adjustments to code that was already done. And his client was the Ycash portfolio management system. It was a financial system. He was talking to bankers, and he was talking to bankers in the late 80s when they understood that debt was actually a risk. Before we got into this idea of everything should be built on leverage and who cares, just file bankruptcy and keep going, right? Today, we don't understand that debt is bad, but back then, they understood that debt was bad. So this metaphor was perfect for that. But here's what happens, and you've probably had these conversations yourself. You're talking to somebody, you're talking about a metaphor, right? You're using a metaphor, and all of a sudden, the conversation changes, right? So I might say something like, well, we can't adjust the code and keep it live in production. That's like asking us to change the tires while we're driving the car down the road. And 10 minutes later, you're actually in an in-depth discussion about the possibility of raising a car off the road and changing the tires on the fly. And so, right, like, you're not talking about the code anymore. You're talking about the thing that was the replacement. And this is what I call metaphorphosis. This is when metaphors go wrong. When we talk about the replacement object so much, we forget what we were actually talking about. And this is exactly what happened with the technical debt metaphor. People heard the term technical debt and they went, debt. I know what that is. And they started talking about things like credit card debt and home interest loans and student loans and voluntary versus involuntary debt. Blah, 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 blah. And still, until they were actually talking about inadvertent reckless debt in the third quadrant, which we will cover in a little bit. This became so common in our industry that our own leaders started to parrot this noise back to us. They started talking about technical debt as if it meant something other than what Ward intended. And I know most of these folks, and I respect all of these folks, but these are the things that some of our leaders started telling us, right? James Shore said, oh, technical debt cut a lot of corners. Martin Fowler talked about it being quick and dirty. Steve McConnell says it's just hacking it in, right? It became extremely pervasive. Fowler himself, who, by the way, many, many people actually thought that Martin Fowler came up with the concept of technical debt. And that is because in about 2009, Fowler responded to a bunch of chatter in the industry. See, there was a bunch of discussion about technical debt. What is or what is not technical debt? February of that year, I had done a blog post basically stating that messy code is not technical debt. A couple of months later, Uncle Bob did a very similar blog post, and like the community just started talking quite a bit about what is or isn't debt. And Fowler basically came out and said, look, this is not a worthwhile discussion, right? We don't need to worry about if it is or is not debt. What we need to think about is where did it come from and what should we do about it? I had the good fortune of being at ThoughtWorks in 2009, and I was on the beach, which means that basically I didn't have a project to work on. And so I was sitting at a table next to Martin Fowler while he was actually crafting the technical debt quadrant. And he and I argued over it a lot. I didn't convince him of anything. He went ahead and made the quadrant. And we'll talk about this now. So this was Fowler's concept, saying, look, we shouldn't be talking about whether it is or isn't debt. We should just kind of look at where it comes from and think about how we should respond to it. So what he said was, debt comes from basically prudent behavior. We are doing things very well. Or reckless behavior. Right? I'm asking you this so it's for you. Prudent behavior or reckless behavior. Reckless behavior, we are not behaving professionally. Right? We are doing things that might cause quite a bit of trouble. Right? In addition, it is either deliberate behavior or it is inadvertent. So we are intentionally doing this thing or we don't realize that we're doing this thing. Right? And this is our technical debt quadrant. So he goes on to explain a little bit further. So if we talk about behavior that is inadvertent and reckless, so we are doing bad things, but we don't know that the things we are doing are bad, it might be something along the lines of, we just don't understand architecture very well, right? We don't know how to actually put the application together well. If we are behaving recklessly and deliberately, now, we're doing something that we probably shouldn't do, and we know that we probably shouldn't do it, but we've made the decision anyway. So this is something more along the lines of, we don't have time for that design crap, let's just start writing stuff, right? He says inadvertent and prudent, which, by the way, this confused me for a long time. it was difficult for me to understand how you could accidentally behave well. Right? But what he actually means is you are behaving well and you accidentally take on debt. Ah, okay. What does that look like? He said, well, that means now we know how we should have done it. And that makes sense, right? We put something in production, the market responds to it, and we realize, should have done something a little bit different. And now we know what that is. And he goes on to finally explain that prudent and deliberate, so I'm behaving well, and I'm doing it on purpose, is we must ship now and deal with consequences. All right? Now, this quadrant always kind of irked me. And we'll get back to this in a little bit. We're going to actually decompose this as we move forward. But right about the time that Fowler published this thing saying, hey, it doesn't matter if it is debt or isn't debt, right? Whether it's, blah, blah, blah. Let's all just kind of get together and have a hug and make sure that we, support each other. Ward came back out and said, sorry guys, but some of you have confused the debt metaphor with the idea that you could write code poorly, right? With intention of doing a good job later. You've confused the metaphor. Like, this is not what I meant at all. He actually goes on and says, here's the deal. The ability to pay that debt back depends on you writing code that's clean enough to be able to refactor as you come to understand the problem. Clean enough to be able to refactor. What is refactoring? Anybody have a definition of refactoring?
Small steps, small transformation.
Small steps, small transformations. What's critical about refactoring?
Don't change the behavior.
It doesn't change behavior. Exactly. Refactoring, we are changing the implementation without changing the behavior. That is what refactoring is, right? If you are ripping it a new one, you're probably not refactoring, right? Now, how do we know with certainty that the behavior is not changing? How can you know that? Tests. Correct. So, if the code has to be clean enough to refactor it, that also means that it has to be well covered with tests, right? It fundamentally means that clean code and good test coverage are prerequisites for technical debt. You cannot have technical debt unless you have clean code. So there is no possible way that not clean code should be called technical debt, right? He goes on to say one last thing on Twitter. He gets on Twitter and he says, all right, fine, you want this metaphor? I'll give you this metaphor. Don't think you're ever going to get your code back, right? Dirty code is to technical debt, is to debt, as the pawnbroker is to financial debt. Right? You're never going to get that code back. Forget it. So the question then for a lot of folks is like, all right, wait a minute. Well, how do I know if I have technical debt or I don't have technical debt? So this is kind of my measure, the way that I look at this. You want to know if you've got technical debt? Ask yourself a couple of questions, a few questions. Is the code actually clean? Is it tested? Is there a learning objective or event? So did you do this on purpose because you wanted to learn a thing? Or did you put it out there and then learn a thing, right? Is there a plan for payback, and is the business truly informed? Now, when I talk about a plan for payback, I don't mean, meh, throw it in the backlog, someday we might kind of get to it, right? I mean an actual plan for how you're going to do this. And the business being truly informed is not, man, we kept trying to tell them, but they weren't listening. Like, they're actually involved in understanding that this is a risk and that we have made this calculated risk, or we have discovered this risk, and we are going to do something about it, right? If you say no to even one of these things, then you don't actually have technical debt. The odds are you have something entirely different. What is that thing that you probably have? If the code is not clean, if it is not tested, if the business is actually not informed, what do you probably have? Well, you probably have a mess, right? And after some searching, I found the perfect word. It's not mess, it's actually CRUFT. CRUFT is an unpleasant substance. It's the result of shoddy construction. And according to several dictionaries, it is redundant, old, or improperly written code. That's the word you're looking for. It's not technical debt, it's CRUFT. Now, I've had a number of people, I've given this talk several times, I've had a lot of people say to me, all right, I hear you, that's great, but it's really just semantics, right? Like, you want to come up with another word when we're all using technical debt. It's really not a big deal, dude. It's just semantics. My response to that is, it's not just semantics, because if we agree that technical debt is good, which we agreed to in the beginning, and we agree that quick and dirty is technical debt, then we agree that quick and dirty is good. And I cannot abide by that. I've never seen a project that starts quick and dirty and finishes well. So I mentioned this technical debt quadrant, and then it kind of got on my nerves, right? Martin and I argued about it, and he published it, and it's cool. Take a look at it again. The first thing about this that bugs me, and I'm hoping it actually bugged you a little bit too, prudent, we're behaving well. Deliberate, we are behaving well on purpose. The description, we must ship now and deal with the consequences. Those don't align for me, right? So what I would have liked is for this to have said, let's deploy and gather more information. Now, but it's only one piece of the entire quadrant, right? And there was still something about this that kept bugging me. Every time I looked at it, it didn't feel right. So after a while, I started thinking, okay, how can I prove or disprove this theory, right? What could I do with this thing that would help me sort of get my head around it and decide, like, okay, yep, I'm on board with this, or no, I'm definitely not. And what I decided to do was, what if we took this idea? What if we took this idea of technical debt and we applied it to some other industries? What would that look like? So, decided to look at construction. Now you can look at this and say, oh, well, it's not their fault. The building shifted after it was built. I would love that to be the case, except you can see that the brick lines are all level where the windows are actually not, right? This was terribly done. What about automotive? What about medical? Right? Can you imagine this? Like, can you imagine a family member comes out of surgery and you find out that this has happened, and the surgeon just says, well, you see, we just incurred some health debt during the surgery. It's kind of like you paid for the surgery with a credit card instead of a home loan. Right? Like, this is ridiculous. We wouldn't accept this in any other profession. So here they all are, right? Now, looking at these two, we're going to say these are reckless, right? And they're deliberate. Like, this one may be arguable, but that didn't happen by accident, right? Somebody did that on purpose. So that's reckless and deliberate. We're going to give this person the benefit of the doubt and say that that's reckless and inadvertent, right? It was an accident. I mean, they weren't like, well, I'm going to need this later. I'll just go ahead and sew them up, and right? So that's reckless and inadvertent. Okay. So let's take those and let's put them back on our quadrant. Reckless and deliberate, reckless and inadvertent. When I look at these in other professions, there are other words that suddenly come to mind for me. Irresponsible and incompetent. Reckless behavior is irresponsibility or incompetence. You're either doing it on purpose or it's by accident, right? So if that's the case, then the only thing on this quadrant that is actually technical debt is that which is a result of prudent behavior. And this is consistent with Ward's original definition. So I know this is getting a little heavy, right? It feels a little preachy in some ways. Like, I'm basically telling you, like, whatever you thought was dead, it's not. You're just incompetent, right? No. We all work in systems. Every system is perfect. It produces the exact results it was intended to produce, right? If we want our behavior to change, we change the system that we're in. So let's lighten this up a little bit. Does anybody want to play a game with me? All right, I got a 3-round game. It won't take long, I promise. The game is called CRUFT or Debt. Right? So what we're going to do, 3 rounds getting progressively more difficult. I will show you a sample of code. And feel free to call out whatever you want. Is this CRUFT or is this debt? Right? 3 rounds getting progressively harder. So round 1, we ready? Is that CRUFT or is that debt? CRUFT, universally accepted as CRUFT, right? So before I actually go through this in any more detail, I have a confession on this one in particular. Are any of you familiar with a website called the Daily WTF? Anyone? Okay, so we got a few, right? So these days it's called the Daily Worse Than Failure. When it first started, it stood for something else. The Daily WTF was started by 2 gentlemen, Alex Papadimoulis and Jake Vincent. And what happened was Alex and Jake were on a team together at a relatively large financial institution in the Midwestern United States, and they got sick and tired of looking at all of this ridiculously crappy code. And so what they did was they started pulling the code out of the system, anonymizing it, and publishing it on a website for everyone to basically laugh at and make fun of. How is this a confession for me? Alex and Jake reported to me. These guys worked on my team. We inherited this code base, I swear, right? I swear. We came in late. Somebody else did this. And eventually they had people submitting examples, and it was no longer the bank's stuff. But, all right, so CRUFT, right? But let's figure out what this is all about. So first thing I'm going to do is just collapse these curlies so we get a little more readability. Okay, much better, right? At least I can increase the font size. All right, so you don't have to read through all of this, and anyone that's trying to, more power to you, right? But one of the things that we can see is like, we're basically iterating through every single table, every single row, every single column, and we're looking for basically an agent ID. So there's definitely like a smarter way to do that, right? We don't have to iterate through all this crap. So let's just get rid of that stuff, right? And assume that we know what we're looking for, because it seems like we do. All right, and then we're going to actually, we're going to go through and originally I was going to add a bunch of abstraction here, create some classes that actually receive data sets, and then return collections of objects. I'm not going to show any of this code because it's basically what any ORM would do, right? But it'll help to clean this up a little bit more. Okay, so now we're getting down to something that's almost readable, right? And we can kind of see what this does. It goes through a list of agents, goes through a list of skills, looks through queues, I'm not sure what the heck that is, and then basically for every skill that the agent has, it actually adds it to an agent queue skill. And it turns out if you actually sit here and think about this for a little while, this should be a view in the database. This is fundamentally just a join on agents and skills, right? It's data that's already there, and we're just building a temporary table. So this code doesn't need to exist at all. That entire thing is basically a no-op if you just push it back to the database where it belonged, right? Okay, so next round, how about this? CRUFT or debt? I'm getting CRUFTs, mostly CRUFTs, right? Anybody, any debt? Okay, CRUFT. So why is it CRUFT?
No test.
Fair enough, no test. The business is probably not informed either, right?
Magic numbers?
Okay, yes, right? Magic numbers, hard-coded literals. No methods with meaningful names. Exactly. So I can actually parse this mentally, right? I can look at this and I can see that it's checking to see if the customer state is Alabama, if it's a general agent type, and the customer revenue is over 100,000, I don't know 100,000 what's, but 100,000 somethings, right? Blah, blah, blah. I can read all of that, but I still don't know what it is that it does. I don't know what any of that actually like means in a business context. So there's a universal cure for that problem. There. Now it's not CRUFT, right? No. It turns out that if you can do that, then you can do one better, right? The other thing that I notice about this is because I'm interrogating the customer all over the place, I don't know what, just looking at this snippet, I don't know what class this is in, but I know it's not in the customer, right? And I've clearly got some kind of feature envy or at least, some, intimacy that shouldn't be happening here, right? Seems to me that if we actually move this method into the customer class, it would automatically clean itself up, and then this code would look much simpler, right? Okay, last round. This is the hardest round. It's also a bonus round. There's a joke in here. Anybody get the joke? I heard someone whisper Monty Python. Yes, right? African or European swallow? All right, so is this CRUFT or is this debt? A lot harder to answer, isn't it? Debt? I got CRUFTs and debts. You know what the right answer is here? It depends. Now remember, I'm a consultant, so that's ultimately always the right answer. But this, in my opinion, this comes down to team agreements. Right? What we're looking at here is fundamentally a nested conditional, right? We use a switch statement so that it looks a little bit cleaner, but this is basically if, else, if, else, if, else, right? And if you read Uncle Bob's stuff, right? How many of you know who Uncle Bob Martin is? Clean code, the clean coder, all that? Right, yeah. If you read his stuff, this is definitely CRUFT, right? When I got to the second condition, then I should have automatically used polymorphism to abstract all this out, right? Or possibly some kind of a compositional aspect, right? But it really is only 3 conditions. And it really does read, fairly easily. And if we know enough about kind of the business context, we may never need to add a 4th condition to this. So it really comes down to what does your team actually agree on, right? But I think we can all agree that at some point, whether it be 2 conditions, 10 conditions, 100 conditions, at some point, we actually want to use polymorphism or something else to actually clean this thing up and move responsibility out of this class, right? The challenge with this is when we do it, because the conditions are relatively tightly packed, it actually moves stuff around. And for some teams that feel like, hey, this code's actually harder to find. Now, of course, it's much more extensible, right? I can add a new swallow type without modifying any of the original code. But it really does kind of depend on what the team agrees to, right? So fundamentally, CRUFT is a bad decision. It's kind of hard to tell sometimes when it's actually CRUFT or isn't, but it's a bad decision because you are, in fact, a professional developer. This is what you do for a living. This is your job, right? And it turns out that you are going to create unintentional CRUFT. You can't help it. It's unintentional. I know for myself, there have been plenty of times where I've picked up a code base that I haven't looked at in a couple of years, and I've read through a class, and I've found some method, and I've gone, what idiot wrote this? And then git blame tells me it was me. Right? Me 2 years ago is just not as smart as me today. I hope that pattern continues. You're going to have to eventually clean up the existing CRUFT. Right? We made it by accident, but it's going to get in our way. We need to actually clean it up. Right? And here's the trap. The trap is there's a precedent in most organizations for speed over quality already. And if what you've been doing is cutting corners to move fast, you've helped to establish that precedent, right? That speed matters more than quality. And now you're starting to actually get yourself into this weird situation. The second thing that happens is most of us are in an environment where the Agile has been installed. And if you're not, you probably will be soon, right? And any time that that happens, somebody in management read one of the books, and many of the books say that somewhere around the 4th or the 5th iteration, velocity stabilizes and goes up, right? Nobody says how. It's just part of the magic. So there's an expectation that your velocity is going to increase. And there's often an expectation it's going to increase indefinitely, which is yet an entirely another problem, right? But the CRUFT is slowing you down. And so the only way to move faster is to write more CRUFT. But right, eventually we just can't do it. And what happens? What happens is then we actually have to ask permission to do our jobs correctly. Now this manifests in a number of different ways. I've seen this in a number of different formats. Sometimes it is that we start to say, hey man, we got to clean up some of this debt. And we start to introduce this idea of technical debt. And what we're actually talking about is CRUFT. But we introduce this idea of technical debt, and maybe we start making cards and we hope that we're going to get it scheduled, right? More often what I see is the much more creative approach of, we realize the entire system is in Java 7, and the latest release of Java provides us blah, 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 right? We come up with some technical reason that we have to do a complete rewrite. It's bullshit, but it's what we use, right? It's easier for us to do that than to admit that we got ourselves into a bad situation. Now the challenge with this approach, with the rewrite approach, is after we've made the argument, after we get the approval for the funding, and the rewrite project starts, what's expected? What's expected is you do it as fast as possible so that we can get back to writing good, new features. So you just put yourself right back in the same position, right? So what we really need to do is manage the CRUFT in some way. And there are two kind of approaches to managing CRUFT that I've seen. One is very common, but I think it's a failing strategy, and one is less common, and I think it's a winning strategy. So the failing strategy is the cleaning sprint, right? How many of you have these? And you don't have to be agile to have a cleaning sprint, right? This is basically, at some point, we're going to take a timeout and we're going to clean up a bunch of stuff, right? We're going to clean up our mess. But we're going to defer all of that stuff till later. This is the designated time to do good. This is the designated time to do whatever is the thing that we don't call good, right? And we're going to focus on speed and velocity at all other times. Well, here's what happens. This is an old study, but it's a good study. They looked at these projects and they said, okay, the cost of change on a project where the black line here is an application where there's basically no refactoring, no cleaning, and the habits are not awful, but we've never gone back and just said like, oh, we should probably clean up some of our unintentional CRUFT, right? And we can see kind of what happens over time. This curve is starting to get to the point where, not too long in the future, basically the cost of change is so high you can't do anything with the application, right? And that's when we start, usually somewhere around here is where we start calling for the rewrite. Somewhere around here is where we get the approval for it, right? The line down here, this green one, is a team that has been cleaning consistently. Now we can see that it's still getting harder. It's still, the cost of change is going up, but this is, the code base is getting larger, the solution is getting more complex, right? It's clean, it's easier to maintain, but there's always an increase in cost of change. So the interesting one is this purple line here, right? And what they discovered was these teams that were following this kind of cleaning pattern, in the beginning everything was okay, but over time you couldn't clean enough to keep up. And the other thing they noticed was as soon as you did a cleaning sprint, the very next sprint was high pressure, start getting stuff done. Because we just spent like 2 weeks doing nothing but cleaning things, right? So it basically turned out that the quality of the code, the cost of change, was insignificantly different for the cleaning sprint strategy. The winning strategy actually is to just clean constantly, right? Don't make it an intentional mess in the first place. Monitor your, I'm doing air quotes now, technical debt, because what we're really talking about is monitor your CRUFT, right? Know where the code is crappy, right? Follow the Boy Scout rule. And I apologize, this is very kind of US specific, but does anybody know what I mean when I say the Boy Scout rule? Yeah, I've got several people. What is it?
Clean your code as you go along. So you get a new class, you open it, you check for CRUFT, and repair it.
And repair it as you go along. Yeah, so the Boy Scout rule is one of the Boy Scout rules is leave the campsite cleaner than you found it, right? Anytime you go into a public park and you use that park, not only do you clean up after yourself, but you clean up something else that's there, right? Just leave it a little bit cleaner. Same idea in our code base. Go in, do your job well, do it cleanly, and just clean up one other thing. It can be small, right? Simple extract method. A simple rename of a variable so that it's more descriptive, right? Decompose a conditional. Just something that's relatively easy to do. But if we all do that, if we all write the code well and do a little bit of cleaning, over time the code base gets better instead of gets worse, and it gets better in the places where we're most commonly making changes, right? So it gets better in the areas where there's lots of churn in the code. So you got something that's way off over here in the distance that no longer gets changed. It does its job, it works. It's ugly inside, everybody's afraid of it, but it just kind of does its job. Leave it alone, right? If you don't need to touch it, don't touch it. Clean the stuff where you're actually adding new features and making new functionality, and you'll make everyone's job a little bit easier, right? And remember that quality is your responsibility. And of course, never ask permission to do your job correctly. This is what we get paid for. We are professionals, right? So if we just do it instead of asking for permission, instead of waiting to be told it's okay, we're in a much better position. We're much better off. So a little bit on monitoring CRUFT. I'm not going to do a ton of detail on this, but a little bit on monitoring your CRUFT. There's certain metrics that I like to look for, and I like to do a combination of metrics. One of the reasons is every single one of these individually is gameable, right? Collectively, as best as I can figure, the only way to game these metrics together is to write better code. So go for it. Game them all together, right? We're going to get the result that we want. So code coverage, right? What is the actual coverage of test coverage in the code itself? Code complexity. I don't care if this is cyclomatic or ABC complexity. Cyclomatic complexity is basically the count of logic branches in the code. ABC is assignments, branches, and conditionals. In either case, what we're doing is we're basically counting the amount of logic paths through the code. And there is a positive correlation between complexity and bugs. I can't tell you if you have a complexity of 142 that you will have 7.4 bugs, right? What I can tell you is the higher the complexity, the more bugs you're going to have. Lower the complexity, the fewer bugs you're going to have, right? Coupling, both afferent and efferent. Right? Coupling has a clear indicator of the brittleness of the code base overall. And there are now metrics out there, there are now tools out there that will actually not just show you coupling in a map, but will actually give you numerical values for afferent and efferent coupling on any given class, any given method. And then if you're in .NET, there's this thing called the maintainability index. And what I like about the maintainability index is it's one number, which indicates quality, and it is actually a heuristic that uses several of these other metrics and just bakes them together into a single, right? Code climate, anybody familiar with code climate? So code climate now runs against probably 10 or 12 different languages, and it will actually give you a score of like A, B, C, or D on both methods, modules, and overall for an application. And it's kind of the same idea as a maintainability index, right? Now, the important part about this is not only monitoring these things, but monitor trends, not points, right? Any value at any given point, any moment in time doesn't matter. What matters is the trending. I don't care if your code coverage is 33% or it's 87%. What matters is where's it trending, right? If it is getting better and you expect it to be getting better, you're doing all right. If it's getting worse and you expect it to be getting better, something's wrong. Take a break, have a discussion. There will be times where you actually expect a metric to get worse, and that's okay. An example, if I have a complex conditional and I want to actually decompose that through polymorphism, the way that I'm probably going to do that is a chunk at a time, right? And I'm going to leave the original code until I've basically written scar tissue all around it, choked it out, and then I'm going to eliminate the original code, right? In that process, I'm going to increase the psychomatic complexity of the code base. I can't help it. I'm writing new code plus leaving all of the old code in place. So it's okay that the complexity goes up. I expect it to, right? So it's never about where it is at any given moment in time. It's only about where it's actually trending. All right, so just to review quick, right? So technical debt, right? It's a strategic design decision or it's a learning event. It requires the business to be informed and includes a payback plan. CRUFT, it happens, it needs to be monitored and cleaned. It is not technical debt. And remember, never ask permission to do your job correctly. Thank you.